Hey class, I get questions a lot in the quadratics unit about how to use the graphing calculator to find all the things that it asks you to find when you're graphing and analyzing a quadratic. So I'd like to just take a few moments to just go through how do you use the buttons on the graphing calculator to do all those things. Like how do I find a min or a max or the zeros and basically everything that you see on this paper right here. So we're going to take a few minutes to go through that. Just so you know, I'm on page 2 of the note packet for Unit 2. So if you want to follow along there, that's fine. But honestly, if you just have other problems that you're working on, you could watch this and just do the same things but do it for your problem, and I bet it would work out just fine. But let's get started. We have the function 3x squared minus 6x plus 7, and we're going to graph that. So let's see, I'll start by just turning the calculator off. So when I turn the calculator on, first thing I would do is go to y equals. That's where you're going to graph it. So I'm going to go to 3x squared, so this is the x button, squared, minus 6x plus 7. Before I graph it, I like to hit the zoom button, and I like to make sure I'm going to get a 10 by 10 window. And so that's just a standard 10 by 10 window. So if you go zoom and then standard, that's how you get that. All right, so there's our graph. There's our parabola. So we can answer a few questions right now just from what we're looking at. So for whether it opens up or down, because the ends of this one go up, this one opens up. So I'm going to circle that now. Also, the y-intercept, I didn't actually even need to graph it to know that one. The y-intercept is always the number at the end. So I know that this hits the ground, it hits the y-axis at 7. So I can go 7, but you can see that right there, how it hits the y-axis at 7. But again, you just look at that and then you know. So now we are on to the rest of them. Because this opens up, the place where it changes directions is at the bottom. So that is our minimum in this problem because it's at the bottom. So this problem has a minimum. And I want to find out what that point is. If I can figure out what that point is, which we call the vertex, so the minimum is a vertex here, I can answer a lot of questions in this page here. So let's do that. So we want to calculate the minimum. To do that, you use the calculate key right there where it says calculate. So because it's up top, we have to hit the second button first. So second, we want to calculate the minimum. So I'm going to go down to minimum. And let's take a look here. So things you see. First of all, let's point out that there's this blinking cursor right here. So if you use your right and left arrows, you see how I can move that around? Don't use your up and down arrows. Only use the left and right, and I can move that around. So the first thing I want to do, and you're going to do the same thing right now, is you're going to move your cursor so it is basically where you think the minimum is. And then the calculator is going to ask you some questions. The first question it says is left bound. So what it's saying is, hey, will you hit, once you're to where you think the minimum is, will you hit the left arrow a few times so that you're like definitely to the left of the minimum? I think you would agree I'm definitely to the left of the minimum there. So I hit enter. And then it says right bound. So it says, okay, so go back to where you think the bottom is, and now hit your right arrow enough so that you're definitely to the right of the minimum. I think you would agree I am definitely to the right of the minimum. So I'm going to hit enter again. Now when it says guess, you just hit enter a third time. And I'm going to sneeze. All right, excuse me. Okay, so the vertex is this point. The calculator is, like I said, it is taking a guess. It's not perfect. So it's actually hitting at 1, and it almost got there, but not quite. So you just know, okay, it has an x-coordinate of 1 and a y-coordinate of 4. So the vertex is 1, 4. Make that look a little nicer. Okay, so the vertex is 1, 4. Yikes, there we go. Once we know that, we can actually answer 2 other questions. So where it says value, what that means is what is the highest or lowest this function ever gets. Because this one is a minimum, it's going to be what is the lowest it ever gets, and that's going to be your y value at the vertex. So the lowest this thing ever gets is at 4. So your value for that will always just be the y value of the vertex. The next question we can answer is the axis of symmetry. Every parabola is basically symmetric, which means if you were to draw a line going straight down here, you can kind of see how the parabola would like fold onto itself. So what you do for that line, where that line is it's always the x-coordinate of the vertex. So we already found that the x-coordinate is 1, so it will be x equals 1. And for the axis of symmetry, you have to write x equals 1. If you don't write the x equals, you don't get full credit. You need to create the equation. For the value, it's fine to just put the y coordinate. You don't have to put like y equals there. But here you do. Anyways, we've just answered a lot of the questions it asked for. The next thing we can do is we can get a table. So to get a table, what you do is you just start by taking the vertex, and that's the point that you're going to put in the middle, because that's the most important point. So I'm going to put 1 and 4. And then the next points we would just go 1, 2, 3. So 2, 3. It'll go 3, 2, 1, 0, -1. So 0, -1. Okay, so to find out the y values at those spots, I'm going to go to my table on the calculator. Right there is the table. So second, calculate. And let's see, at -1, the graph is at 16. So -1 is 16. At 0, the graph is at 7. Remember, the y-intercept was at 7, so when it's at 0, it's at 7. At 2, the graph gets to 7 again. And at 3, the graph gets up to 16 again. The last thing I'll do now is plot those points. So let's plot those. So we've got 1, 4, 1, 2, 4. 2, 7, 2, 1, 2, 3, 4, 5, 6, 7, and then 0 was also at 7, and then at 16 it's off the graph, so we can just kind of go like this, and I've graphed it. Go like this again, and the last thing it says right here, it doesn't say this in your notes, but a thing that you often have to find are zeros or roots. Zeros and roots are where a function hits the ground. So if the ground was right here, I think you would agree that this function never hits the ground. So that's why you don't have to answer it for this question. In another video, I'll show you how to find the zeros or the roots or when it hits the ground. But hopefully that gives you a good start on how to use the graphing calculator, and good luck. Thank you.